Fifth graders, this is Module 4, Lesson 33, Eureka Math, and this is our last lesson of the module, which means that after this we're going to have a short review and then the Module 4 end of module assessment. So today we're going to kind of pull all of it together, bring everything together, do some story problems using expressions, tape diagrams, word problems with fractions, division, multiplication. We're putting everything together now. And it's March, so that means that we're kind of taking everything we've learned up to this point and kind of putting it all together now. You're really going now on 5th grade math. This is great. And after this, we're going to kind of get away from fractions for the next module, and we're going to start getting into measurement and converting measurements, and it'll be great. And then we're going to do some geometry, and we're going to finish the year doing geometry. And Module 5 and Module 6 are a bit shorter. This was the biggest module of the year, so that's good. That's got to feel good. Like we're definitely on the downhill now for the school year. So go to your Learn pages, Lesson 33, last problem set of Module 4. Write your name on the page. Ms. Hayes has half a liter of juice. She distributes it equally to 6 students in her tutoring group. How many liters of juice does each student get? Well, here is our half liter. I'm going to draw a big line here. This is a whole liter, and this is our half of a liter. And she's going to divide it between 6 students. So 1, 2, 3, 4, 5, 6. So how much does each student get? How many liters? So let's write that as an expression. Half of a liter divided by 6 students would equal 1/12 of a liter. Okay, because I know that this is 1/12 of a full liter. So I made a tape diagram. I used division, fraction problems. Don't forget your labels. Okay, this is everything we've been doing up until now. How many more liters of juice will Miss Hayes need if she wants to give each of her 24 students in her class the same amount of juice found in Part A? Well, she wants to give a 1/12 of a liter to 24 students. How many liters is she going to need? Okay, so this is pretty easy. We're just going to multiply across the top. 24 over 12, and that equals 2 liters. She does not have enough. She's going to have to go out and buy at least another 1.5 liters. I think juice comes in liter boxes, so she'll probably have to buy 2, and then she'll have leftover. But then she'll take it home. It'll be fine. Okay. Lucia has 3.5 hours left in her workday as a car mechanic. She needs half of an hour to complete 1 oil change. How many oil changes can Lucia complete during the rest of her workday? So she has 3.5 hours, and she wants to finish her day. She wants to know how many oil changes can she change, or how many oil changes can she do. So she wants to divide this into halves, right? So anyway, okay. So there's our workday. Our expression would be 3.5 divided by half. Now what do we have here? We have decimals and fractions. So now we're going to have to decide, do we want to do this story problem in decimals, or do we want to do this story problem in fractions? Doesn't matter to me. Let's start with decimals, and then we can try with fractions later. Well, or let's do fractions first. You know that 3 5/10 is the same as 3 5/10. Okay? You also know that 3 5/10 is 3.5. Okay, now I'm going to turn that into an improper fraction. 2 times 3 is 6, plus 1 is 7 halves, divided by 1/2 would equal, well, what does that equal? 7. Easy. Okay, how many oil changes can she do? 7. So this would get divided into 7 oil changes. 3, 4, 5, 6, 7. Let's do it as a decimal just to prove that we can. 3.5, or 3 5/10, divided by, and you know that 1/2 equals, I'm going to put this over here, 7 oil changes. You know that 1/2 equals 5/10, which equals 5. Okay, so 3.5 over 5 would look like this. 5/10. I'm going to multiply both of those by 10 to move the decimal point over. Now I have 35 divided by 7. I'm sorry. Look at that. I'm already giving the answer. 35 divided by 5, which equals 7. So if you want to do this with a fraction, or if you want to do this with, with the decimal, or if you want to do this with fractions, it's up to you. As long as you get there in the end and you show your work. Okay? 7 oil changes. Lucia can complete 2 car inspections in the same amount of time it takes her to complete 1 oil change. How long does it take her to complete 1 car inspection? Well, it's half the amount of time. So logically, if it takes 1/2 of an hour for an hour oil change, and it takes her the same amount of time to do 2 car inspections, 1/2 divided by 2 is 1/4 of an hour. I can do a tape diagram if you want. Here's my hour. There's half of it. And she's going to divide it into 2, which is 1/4, right? Okay, how long does it take her to complete 1 car inspection? 1/4 of an hour. How many inspections can she complete in the rest of her workday? Well, if it's 7 oil changes and it takes her half the time to do car inspections, logically we already know that it's 14 car inspections. But we have to show our work. Okay? So let's show our work. She's got 3.5 hours, and she's going to divide it by 1/4 of an hour, and 1/4 is the same as, okay, I'm going to do this little scratch work up here. (25 over 100), so that would be 3.5 divided by 0.25. Okay, so now I can rewrite that as 3.5 divided by 25 hundredths, and then I'm going to multiply that by 100 and this by 100, and then I'm going to have 350 divided by 25, which is 1 here, and 25, and that would give me 100 left, and that would be 4. So 14 car inspections. Okay, here I am showing my work, but logically, you already know. If she can do 7 oil changes in 3.5 hours, she can do 14 car inspections in 3.5 hours. It's a little bit of logic, but you do need to show your work. Okay, these are easy. These are not hard, right? This is just taking everything that we've learned and putting it together. Okay, Carlo, I feel like he lost his S there, Carlos. But I guess Carlo is the name. Maybe it's a little bit more Italian. Carlo buys $14.40 worth of grapefruit. Each grapefruit cost 80 cents. How many grapefruits did Carlo buy? So $14.40 divided by 80 cents. And I can just rewrite that as this by moving that decimal point over. And 1440 divided by 80. Sorry, that's at 0. Okay. You guys want to see a trick? You want a nice little trick? Do you see this fraction? Whatever you do to the top, you can do to the bottom. Let's cut out that 0. Let's cut out that 0. Let's cut out this 0. And let's cut out that 0. And then we're only multiplying 8 into 144. A little bit of, not a trick, just, you know, good math sense. 8 into 14 is 1 with 64 left over. And 8 into 64 is, how much? 8, right? 4, 64, 0. Okay. How many grapefruits did he buy? 18. You know what? I'm going to check my work. If each one was 80 cents, I'm going to do 18 times 80 cents. Nope, sorry. 80 cents times 18. Then I'm going to go 8 times 0 is 0. 8 times 8 is 64. Carry the 1. 8 times 0 is 0. And 8 is 0, 4, 14, 1, 2 decimal points, $14.40. Good. Just double checking my work. 18 grapefruits. I like grapefruit. At the same store, my mom always cut it in half and then put a little salt on it, and then you dig out each section of the grapefruit with a little salt. Ooh, yummy. Some people put sugar on it, but we're a salt family. Definitely a salt family. At the same store, Kari spends 1/3 as much money on grapefruits as Carlo. How many grapefruits does she buy? Well, we could just say 1/3 as much money would be 8 times 3, which 1/3, which would be 6, right? 6 grapefruits. That seems like the easiest way to do it. But let's do it a more complicated way too. So $14.40 times 1/3 would be the same as $14.40 divided by 3, right? So 3 into 14 would be 4. There's 12. $2.40 would be 8. Wait a minute, what am I doing? That doesn't seem right. I'm just checking how much money she did. Okay, yeah, that's right. 24, and then 0, 0, 0. So she spent $4.80, and she got 6 grapefruits. So let's just see, does 80 cents times 6 equal $4.80? Yes, it does. So 6 grapefruits. Okay. Studies show that a typical giant hummingbird can flap its wings once in 1/8 of a 100th of a second. Wow, that's fast. Hummingbirds are fast. While flying for 7 2/10 seconds, how many times will a typical giant hummingbird flap its wings? So we have 7 2/10 divided by 8/100. Okay, so I'm going to rewrite that as a fraction. I'm going to multiply that fraction by 100 over 100 so that I can move those decimals, and my new answer is going to be 720 because I had to add a 0 here, divided by 8, so 720 divided by 8. 8 goes into 72 9 times. Okay, so 90. How many times will a typical giant hummingbird flap its wings in 7 seconds? 90 times. Wow, that is fast. A ruby-throated hummingbird can flap its wings. So this was a giant hummingbird, and this is a ruby-throated hummingbird. Can flap its wings 4 times faster than a giant hummingbird. How many times will a ruby-throated hummingbird flap its wings in the same amount of time? Well, we already said that it was 90 times, so let's just multiply that by 4. 360 times in 7.2 seconds. Wow. That's fast. Okay, wait a minute. We have more. We do have more. Sorry. That's it. One more page. Thought we were done. Create a story context for the following expression. Let's see. Let's start with that $20 bill. Bobby. Spent $3.20 of his $20 allowance. If you don't get an allowance, allowance is what your parents might pay you to do your chores around the house, like take out the garbage or wash the floor, wash the dishes. Okay, so he spent $3.20 of his $20 allowance. Right? He promised 1/3 of the remainder he promised, wait a minute, to save 1/3 of the remainder in his piggy bank. How much will he save? Now we can solve that if you want. 20 minus 3 2/10, or $3.20, would be 80 cents plus 16, right? And then 1/3 of that would be 16 and 80 divided by 3 would be 5. It's 15 and 180 would be 6. $5.60. So how much is he going to save in his piggy bank? $5.60. In Venezuela, it'd be $6 because we don't use change, right? Of course, what he spent would end up being $4 because nobody at the store would have change either. But, okay, create a story context about painting a wall for the following tape diagram. Okay. Painting a wall. Should we say Bobby again? Bobby, that's how he earned his allowance. Painted half the wall and his 3 siblings, his 3 brothers and sisters, are going to paint the remainder. How much of the wall will each sibling paint? Let's go ahead and write an expression for that. So here's the wall. He painted half of it. And the kids are going to paint the rest, right? So here we've got 1/2 divided by 3, which equals 1/6 of the wall. All right. I am excited to read your story problems. Some of you struggled with that this past week, so story problems, let's write some good ones. Okay. And now you can finish up your problem set, go to the exit ticket. Remember, this is an important exit ticket. It's the last exit ticket of Module 4. Please do your best. There is just one question, Part A and Part B. So show all of your work, do your best. Then come back and finish your Lesson 33 homework. Okay, have a great rest of your day. Looking forward for the test.